Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. When you design an IoT device, you often fight the same battle every time. You need more functions in less space. The product must stay light and cost-effective, and assembly should be fast and repeatable. In many cases, the biggest space and complexity generator is the traditional PCB, together with connectors, wires, and mechanical mounting. That's why more and more designers ask a simple question: do we really need a classic PCB here, or can we print the circuit instead? Printed electronics is a method of creating electronic layers by printing conductive, insulating, sensing, or protective inks on flexible materials. Instead of building a rigid board and then connecting everything around it, you can build thin, lightweight circuits directly on substrates like PET film, TPU, paper, fabrics, or even biodegradable foils. The result is an electronic layer that can be integrated into the surface of the product, into the housing, or into an HMI panel, which makes printed electronics especially attractive for IoT, wearables, automotive, and medical devices. There are several printing methods, and the best choice depends on your design, volume, and precision needs. Screen printing is a strong option for larger scale production and for building thicker layers, typically in the range of about 10 to 50 micrometers, which works well for conductive, insulating, and heating inks. Inkjet printing is usually used for very thin layers and high precision, with fine lines that can go down to around 50 to 75 micrometers, so it's often used in prototyping or when the geometry is complex. Pad or transfer printing can be useful when you need to print onto irregular or three-dimensional shapes, like curved housings or buttons. For many industrial applications, sheet-to-sheet printing is a powerful approach because it prints on single sheets of PET, PC, TPU, or paper with very good accuracy, and it fits well with HMI components, sensors, medical strips, and touch panels. Roll-to-roll printing is typically chosen for very high volumes like RFID tags or heating films because it's fast, but it also requires larger investments and longer setup times. The key idea is that printed electronics can sometimes replace not only the PCB, but also connectors and wiring, and it can be combined with graphic layers and functional surfaces, which simplifies the whole product architecture. To make this work, you need the right material set. Conductive inks are often based on silver, but carbon and copper solutions also exist, depending on requirements and cost targets. Substrates like PET are common and come in typical thicknesses such as 50 to 175 micrometers, while TPU is attractive for wearables because it handles bending and softness better. You can also use dielectric and resistive inks to build insulation, resistors, or heaters as part of the same printed structure. When you think in layers, you start designing the function directly into the product, rather than adding separate electronic blocks later. A great example of how precise and repeatable printed electronics can be is the world of blood glucose test strips. These are medical products where accuracy and process stability are critical. A typical strip can include a PET film base, a silver conductive layer, a graphite sensing layer, lamination with a clear protective film, and then cutting into small, consistent pieces. In sheet-to-sheet technology, each layer can be printed with high accuracy, then dried, laminated, and cut in an automated process. This kind of repeatability is exactly why printed electronics work so well in medical applications. And it also shows what's possible when printing is treated as a manufacturing discipline, not as an experiment. So when does it make sense to print instead of using a PCB? If your product needs flexibility in bending, printed electronics is usually far better than a rigid PCB. If you need the solution to be lightweight, printing also has a major advantage. If you want integrated HMI functions, like touch, sensing, or interface layers, printing often wins because you can combine electronics and interface into one structure. On the other hand, if you need complex logic circuits, high-density processing, or advanced computing, classic PCBs are still the natural choice. In many real products, the smartest approach is hybrid, printed layers for sensing, interface, or routing in tight spaces, and a small PCB where you truly need complex logic. This is how you reduce size and assembly effort without increasing risk. If you want printed electronics to behave like a predictable engineering solution, details matter from the first design files. Many designers prepare layers in formats like DXF, CDR, or AI. DXF is especially useful for technical design because it works well with CAD and CNC systems and fits screen printing workflows, while CDR or AI can be better for graphic layers like masks and UI panels. You also need to respect the limits of the printing process. For screen printing, a practical minimum spacing between printed lines is typically around 0.4 millimeters to avoid bleeding and short circuits. And for repeatable results, many designs stay in the 0.4 to 0.6 millimeter range. Conductivity and resistance are also part of the design, not an afterthought. Silver inks offer strong conductivity, and resistance depends on geometry. Thicker and wider lines reduce resistance, and for higher power use, like heaters, you often design wider traces or even print multiple layers with drying in between. Finally, curing is critical. Many silver inks are dried and cured in a controlled temperature window, often around 120 to 150 degrees Celsius, for several minutes, and you always match this to the substrate limits, because PET and TPU behave differently under heat. The bottom line is simple. Sheet-to-sheet printed electronics can be a real alternative to classic PCBs in many IoT projects, especially when you need precision, repeatability, flexibility, and multi-layer integration in a tight space. It's not about replacing PCBs everywhere. It's about knowing where printing removes parts, reduces assembly steps, lowers mechanical complexity, and opens new design freedom. And when you approach it with the right materials, the right process limits, and proper validation, printing isn't less reliable. It's simply a different engineering route to the same goal, a robust product that is easier to manufacture and easier to scale. Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. This episode of LC Insider was powered by LC Electronic, where printed electronics meet precision engineering. Visit lcelectronic.com to explore materials, cases, and technologies we talked about today.